Hello all, welcome to Unacademy. Let's crack it. Okay. So crack GATE and ESE with India's largest learning platform. Get Plus subscription and access unlimited live and recorded courses from the India's best educators. Now before going to start this, let me introduce myself. Myself Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Now here you can go through it, how to install the Unacademy's learning app. In this app you will get either plus subscription, manage your goal, take plus subscription or iconic subscription. It is up to you, whichever is suits to you. Okay, what you will get in that subscription plan. So you will get daily live classes, live test and quizzes, structured courses, unlimited access you will get. Now for the iconic subscription, take your GATE and ESE preparation to the next level with a personal coach. This is the most important benefit of the iconic subscription. Here you will get a personal coach, get one-on-one guidance from the top exam experts as your personal coach, align your preparation strategy and learning resources. Mains and question answer practice you will get. Strengthen your mains and answers writing through the regular practice with the evaluation and personalized feedback. Study tracker you will get. So you will get here participated in the study tracker plan and study booster workshops. Evaluate your progress in by weekly reviews with the personal coach. Now you will get all benefits of Plus in the iconic subscription. So live classes from the top educators, mock test and quizzes, Structured batch courses in line with the exam syllabus you will get in the Iconic subscription. Okay, what you will get in a plus subscription? So you will get the plus subscription plan in which you will get daily live classes. Okay, so chat with your educator, engage in discussions, ask your doubts and answer polls all while the class is going on. Now in live tests and quizzes, you will get evaluate your preparation with our regular mock test and quizzes and get the detailed analysis on your performance. Okay. Now structured courses, all our courses are structured in a line with your exam syllabus to help you the best prepare for it. Okay, now your unlimited access also you will get. One subscription gets you access to all our live and recorded courses to watch from the comfort of your any devices. Now learn with the top educators. So you can see here, these are the some top educators of Unacademy. Marut Tiwari sir, then Ankit Goyal sir, Sanjit Jain sir, Jaspal Singh sir, here you will get. Now these are the another uh, here you will get the top educators of Unacademy. Now see, these are also some top educators of Unacademy. Now you will get GATE and ESE courses here. So there are many courses are available for GATE and ESE for each and every branch of engineering. So from ESE you will get 10 courses, mechanical engineering you will get 24 courses, electrical engineering you will get 18 courses. So you can see there are lot of number of courses are available for each and every branch of engineering. Now see, in short, you will get in a plus subscription, India's best educator, interactive live classes, structured courses and PDFs you will get, live test and quizzes also you will get in the plus subscription. Now in Iconic subscription, all the benefits of plus here you will get, that is India's best educator, interactive live classes, structured courses and PDFs, live test and quizzes you will get. Now personal coach, the most important benefit of Iconic subscription is here you will get a personal coach so that you can take your study to the next level with the help of your personal coach. Now personalized test analysis is there, study planner is there, preparatory study material is also there. So these are the additional benefits of Iconic subscription. So if you want to get a top rank in the GATE exam, so I will suggest you go for the Iconic subscription. Now see, for the plus plan, so for the plus plan, the subscription for 1 month is rupees 5,500. But if you go for the 12-month subscription plan, so it will cost you 30,250 only, right? The subscription plan, it will cost you 30,250, and in this you will get the if you use my promo code DSP, then the same subscription plan you will get it for 27,225. So I will tell you here this. So I will tell you here that this subscription plan for the you will get, if you use my promo code DSP, then you will get a 10% discount here. Now I am going to tell you here the discount amount will be less after some period. So this discount is for the limited period. So as early as possible, you can enroll your name in the plus plan or Iconic plan. Now Iconic subscription is for 12 months. It is cost for 50,250, and the same plan, if you use my promo code DSP, that will cost you for 45,225. So it's a better benefit you will get after using my promo code. So use it and go through it. So enroll today for this Iconic plan. And the most important thing is here, evolve for the GATE 2022. The batch C is already started for the civil engineering. To enroll in this batch, you can use my promo code to get the 10% discount. Now for the batch C, ascend for the GATE 2023 for the civil engineering is also started. To enroll in this batch, you can use my promo code DSP to get the 10% discount. For batch A, involve for the GATE 2022 for the chemical engineering. To enroll in this batch, you can use my promo code DSP. Now ascend for GATE 2023 for the mechanical engineering, you will get the batch C here. So use my promo code DSP to get the 10% discount. Now see, now we will start our triple integration. Okay, we will start it here, triple integration. Before going to start this, you must have to remember some formulas. First, for the complete sphere, right? For complete sphere, we must know x square plus y square plus z square is equal to a square, right? R is equal to 0 to R is equal to a. Theta is varying from 0 to pi and phi is varying from 0 to 2 pi, right? R is varying from 0 to a, theta is varying from 0 to pi and phi is varying from 0 to 2 pi. Now for the hemisphere, x square plus y square plus z square, you must have to remember which is equal to a square where z is greater than or equal to 0. So limits are r is varying from 0 to a, theta is varying from 0 to pi by 2, right? Theta is varying from 0 to pi by 2 and phi is varying from 0 to 2 pi. Okay, so you must have to remember these limits while solving any examples on triple integration. So third one is for positive octant of a sphere, for positive octant of a sphere, you will get limits are 0 to a, theta is varying from 0 to pi by 2 and phi is varying from 0 to 2 pi. Right? You must have to, sorry, for the positive octant, the phi is varying from 0 to pi by 2. Okay. Now for the ellipsoid, to solve any example of triple integration, you must have to remember this. For ellipsoid, x square by a square plus y square by b square plus z square by c square is equal to 1. Then we can use here x is equal to ar sine theta cos phi, y is equal to br sine theta sine phi, right? Z is equal to cr cos theta, Z is equal to cr cos theta, and dx dy dz is equal to abc r square sine theta into dr d theta d phi, into dr d theta d phi, right? So you get our limits. R is varying from 0 to 1, theta is varying from 0 to pi and phi is varying from 0 to 2 pi, right? Phi is varying from 0 to 2 pi. Now you must have to remember the Dirichlet conditions also. Okay. So for this, I'm adding one slide here. For Dirichlet condition, or Dirichlet's theorem. Many times we will use it. Dirichlet's theorem. If x plus y plus z is less than or equal to 1, then triple integral x raised to a minus 1, y raised to b minus 1, z raised to c minus 1, dx dy dz is equal to gamma of a, gamma of b, gamma of c upon 1 plus a plus b plus c. Okay. So these are the Dirichlet conditions. So we will use this formula while solving any example on triple integration, right? So let's start our first example of triple integration. Now evaluate integral from 1 to e x, integral varying from x to x square, integral of 0 to log x dz dy dx. So you will get here dz dy dx. So for this step 1, let I is equal to, let's start with, now these are the limits of z, these are the limits of y, and these are the limits of x, right? So first integrate with respect to z, and then with respect to y, and then with respect to x. Okay. So let's start. I is equal to integral 1 to e, integral x to x square, integral 0 to log x into dz dy dx, right? So integral from 1 to e, integral from x to x square, and integration of 1 dz is z. And the integral limits are 0 to log x dy dx. So integral from 1 to e, integral from x to x square. Here log x minus 0 dy dx. Integral from 1 to e, integrating with respect to y, right? So you will get y into, here log x is constant. So we will keep as it is, log x bracket y from x to x square dx, right? So you will get integral from 1 to e log x into bracket x square minus x dx. Okay, so we will apply here integration by parts. So here is u, here is v. So by using LIT rule, so return the first into integral of second. So x cube by 3 minus x square by 2 minus integration of derivative of first, that is 1 by x, into integral of second, x cube by 3 minus x square by 2 dx. Okay, so here integral limits are 1 to e. So put x is equal to e. So log e into bracket e cube by 3 minus e square by 2 minus log 1, 1 by 3 minus 1 by 2 minus, now see calculate integration of 1 to e, x square by 3 minus x by 2 dx. Okay. Now see, so integration for this is log of, so here log e is 1. So 1 into bracket e cube by 3 minus e square by 2 minus, here you will get log 1 is 0. So this one is 0, right? This value is 0 minus integration of x square by 3. So x cube by 9 minus x square by 2. It means x square by 4 you will get from 1 to e. So which is equal to e cube by 3 minus e square by 2 minus x cube by, here e cube by 9 minus e square by 4 minus 1 by 9 minus 1 by 4. E cube by 3 minus e square by 2 minus e cube by 9 minus e raised to 2 by 4 minus, here is 4 minus 9 minus 5 by 36. So minus minus plus 5 by 36. Right? So you will get e cube by 3 minus e square by 2 minus e cube by 9 minus e square minus minus plus e square by 4 minus 5 by 36. So here, so multiplying by 3. So 3 e cube by 9 minus e cube by 9. So you will get 2 e cube by 9 here minus e square by 4. So minus 2 e square by 4 and plus e square by 4. So minus e square by 4 and plus 5 by 36. This is the correct option. Okay. So you will get the correct option. Now solve this integral. Okay. Now this integral of this integral from 0 to a. Can see integral from 0 to a, integral of root of a square minus x square, integral from 0 to root of a square minus x square minus y square, x y z dx dy dz. Right? So let's start here. This is spherical. We will use this spherical polar coordinates because see here, these are the limits of z is equal to 0 to x square minus x square, a square minus x square minus y square. These are the limits of y and these are the limits of x. Okay. So here we can see we can write I as I is equal to integral from x is equal to 0 to a, integral from y is equal to 0 to root of a square minus x square xy, integral from z is equal to 0 to root of a square minus x square minus y square z dz dx dy. Okay, so you will get here I is equal to integral from 0 to a, integral from 0 to root of a square minus x square xy into here z square by 2. So 1 by 2 into z square, 1 by 2 into z square dx dy. Right? So first dy dx, dy dx. So use the integral limits from 0 to root of a square minus x square minus y square. So I is equal to, we will get I is equal to integral from 0 to a, integral from 0 to root of a square minus x square into xy 1 by 2. Z square is, so square root is gone, a square minus y x square So you will get a square minus x square minus y square into dy dx right? So what you will do, I is equal to integral from 0 to a, so integral from 0 to root of differential integrating with respect to y, so x constant, right? So only we will get the differentiation of this is x by 2 from a square minus x square into y square by 2 minus y raised to 4 by 4 from y is equal to 0 to root of a square minus x square dx. So integral from 0 to a x by 2 into bracket a square minus x square into y square. So you will get again a square minus x square. Right? A square minus x square by 4 minus 1 by 8 into a square minus x square bracket square. Root cancel up dx. So integral from 0 to a x 2 is already taken inside. So 1 into x by 8 a square minus x square dx is equal to 1 by 8. Integral from 0 to a, we will get x into a raised to 4 minus 2x square a square plus x raised to 4 dx. Right? So which is equal to 1 by 8 integral from 0 to a 1 into x by 8 or dx, right? So 1 by 8 integral from 0 to a raised to 4x minus 2 a raised to 2x cube plus x raised to 5 dx, which is equal to 1 by 8 into a raised to 4 into x square by 2 minus 2a square into x raised to 4 by 4 plus x raised to 6 by 6 from 0 to a. So you will get 1 by 8 into bracket a raised to 6 by 2 minus 2a raised to 6 by 4 plus a raised to 6 by 6, right? So taking minus 0, we will get everywhere is 0. So we can see, so the denominator we can make it here 6. So ultimately here a raised to 6, it means you will get least common multiple 2, 4, 6, 6, 3 a raised to 6. Here you will get 2 a raised to 6 minus 2 a raised to 6 upon 4 plus a raised to 6 by 6. So this will get cancelled out. So you will get 1 by 8 into a raised to 6 by 6. So which is equal to a raised to 6 upon 40. This is the final answer. Okay. I hope you are getting it clearly. Now evaluate integral from 0 to 1, 0 to 1, 0 to 1 e raised to x plus y plus z dx dy dz. So let I is equal to integral from z is equal to 0 to 1, y is equal to 0 to 1, x is equal to 0 to 1, e raised to x into e raised to y into e raised to z dx dy dz. So integral from z is equal to 0 to 1, y is equal to 0 to 1. So first integrate with respect to x, right? First integrate with respect to, we will get here x. So e raised to yz common. So e raised to y into e raised to z is constant. So e raised to x from 0 to 1 dy dz. So integral from z is equal to 0 to 1, y is equal to 0 to 1. E raised to 1 is e. So you will get e raised to 1 minus e raised to 0 is 1. So e raised to 1 minus 1 into e raised to y into e raised to z dy dz. Right? So we will take e raised to e raised to 1 is e minus 1 is constant. Integrating from 0 to 1, e raised to z into e raised to y from 0 to 1 into dz. So e raised to e minus 1, that is equal to 0 to 1, e raised to 0, e raised to 1 minus e raised to 0 is 1 dz. E minus 1 into e minus 1, integral z is equal to 0 to 1 e raised to z dz. E minus 1 bracket q is the correct option. Okay. Now let's see. Integral from 0 to 1, integral from 0 to 1 minus x, integral from 1 minus x minus y dx dy dz. Now integrating first with respect to z, right? So here is dx dy 0 to 1 minus x minus y dz. So integral 0 to 1 dx, integral 0 to 1 minus x dy into z from 0 to 1 minus x minus y. One minus x into 1 minus x, right? Y is equal to x square. 1 minus x bracket square by 2 dx, right? So which is equal to integral from 0 to 1, 1 by 2 so 2 into this, so you get only this 1 by 2, 1 minus x bracket raised to 3 by 3 and this minus 1 from 0 to 1. So 1 by minus 6 into bracket, so 1 by 6 minus 1, no? What I understand? Plus 1. So answer is 1 by 6. Minus of minus 1 by 3 plus 1 by 3 into 1 by 2. So 1 by 6 is the correct option. Right? Integral from 0 to 2, integral from 0 to x, integral from 0 to 2x plus 2y e raised to x plus y plus z dx dy dz. So I is equal to integral from 0 to 2, 0 to x. Integral from z is equal to 0 dz dy dx to x plus 2y minus e raised to x plus y plus z, you will get upon 1, right? From z is equal to 0 to z is equal to 2x plus 2y dy dx. Minus 1 e raised to 0 is x plus 1, right? Dy dx. Plus e raised to x by 1 from 0 to 2, right? Uh, into e raised to 9, e raised to 9, e raised to 3. Integral from 1 to a raised to 3 by 3, right? From 0 to 2. So you will get e raised to 12 by 18 minus e raised to 6. E raised to minus 6 by 9 minus e raised to 4 by Now let's see the triple integral x square yz dx dy dz through the whole volume bounded by the planes x is equal to 0, y is equal to 0, z is equal to 0, and x by a plus y by b plus z by c is equal to 1. Okay, so how we can integrate this? So put here x is equal to au, y is equal to bv, z is equal to cw, dx is equal to adu, bdv, u plus v plus w is equal to 1. So once you are getting it here, u plus v plus w is equal to 1. It means here we can apply the Dirichlet's theorem. See, how we'll apply by Dirichlet's theorem. By Dirichlet's theorem, I is equal to triple integral au square into bv into cw, adu into bdv into cdw. Gamma of 3, gamma of 2, gamma of 2. So easily you will get a cube into b square into c square into 2 upon 5040. Why 5040? Because here gamma of 3 plus 2, 5 plus 2, 7 plus 8. So 8 factorial will get 5040. Right? Now, in triple integral xyz dx dy dz over the positive octant of a sphere, x square plus y square plus z square is equal to 4. Positive octant of a sphere, x square plus y square plus z square is equal to 4. So see here we can evaluate the integral I is equal to, now V is the volume bounded by the sphere in a positive octant. So we will use the spherical polar coordinates, right? X is equal to r sine theta cos phi, y is equal to r sine theta sin phi, z is equal to r cos theta, right? So let's see. The integral limits are not given. So we can use the spherical polar coordinates by spherical coordinate system. X is equal to r sine theta sin phi, z is equal to r cos theta. R is varying from 0 to a. Theta is varying from 0 to pi by 2. Why? Because it is positive octant, right? So theta is varying from 0 to pi by 2 and phi is varying from 0 to pi by 2, right? Phi is also varying from 0 to pi by 2, right? So we will get whole integral is I is equal to phi is varying from 0 to pi by 2. Okay. Theta is also varying from 0 to pi by 2. And r is also varying from 0 to 2. R cube sin square theta into cos theta into cos phi sin phi into r square sin theta dr d theta d phi, right? So which is equal to integral phi to 0 to pi by 2 sin to phi upon 2 cos phi sin phi. So multiplying and divide by 2. 2 sin phi cos phi sin 2 phi by 2, okay, into d phi. Sin cube theta cos theta d theta. One upon 1 by 4 into sin raised to n. You know that the formula for sin raised to n theta from 0 to pi by 2. So you will get here 1 upon n minus 1 n plus 1, right? 1 by 4 into r raised to 6 by 6 from 0 to 2, right? So you get integral limit sin raised to m theta cos theta d theta is 1 upon m plus 1. So thing. Since here we want to, we can write down 0 to pi by 2 sin raised to n theta cos raised to cos theta d theta is equal to 1 upon n plus 1. So here m is equal to 3. M plus 1 you will get 4. So minus cos pi by 2. 2 to get cancelled out. Cos pi is minus 1 and minus of minus 1 plus 1. So you will get 1 by 4 and cos 0 0. So minus of 1 by 4 into minus 1 minus 1. Into 1 by 4 to 2 raised to 6 by 6 minus 0. So 2 by 4 minus 2 minus 1 minus 1 minus 2 and this minus plus 2 by 4 into 1 by 4 into 2 raised to 6. That is 2 raised to 6 by 6, right? So 2 raised to 6 by 6 into 2 raised to 6 by 6, which is equal to 4 by 3. And calculate. 4 by 3 is the correct option. I hope you are getting it clearly. Now, triple integral over v x square y square plus y square z square plus z square x square dx dy dz, where v is the volume bounded by the sphere, x square plus y square plus z square is equal to a square. Okay, so we will use x is equal to a root u, y is equal to a root v, and z is equal to a root w, right? So dx is equal to a upon 2 root u du, dy is equal to a upon 2 root v dv, which is equal to, here you will get a by 2, there is a by 2 u raised to minus 1 by 2, a by 2 u raised to minus 1 by 2 du, okay? And here is dv is equal to, you can calculate dv is equal to a by 2 root v dv is equal to a by 2 v raised to minus 1 by 2 dv. So dy is equal, sorry, dy is equal to dz is equal to a upon 2 root w dw is equal to a by 2 v raised to minus 1 by 2 dw. Just substitute it. So x square upon a square is equal to u. Y square upon a square is equal to v. Y square upon a square plus z square upon a square is equal to 1 becomes u plus v plus w is equal to 1. Right? So by considering the positive octant of the sphere, by considering the positive octant of the sphere, will get I is equal to the triple integral a raised to 4 into uv plus a raised to 4 into vw plus a raised to 4 into uw into a cube by 8 into 1 upon root u into root v into root w into du into dv into dw. So I is equal to triple integral a raised to 7 by 8 uv plus vw plus uw into u raised to minus 1 by 2 into v raised to minus 1 by 2 into w raised to minus 1 by 2 du dv dw. Right? Du dv dw. So which is equal to triple integral. Now a raised to 7 by 8 is constant. So u raised to 1 by 2, u raised to 1 by 1 and u raised to minus 1 by 2. This will becomes u raised to 1 by 2 into v raised to 1 by 2 into w raised to minus 1 by 2. Right? Plus u raised to minus 1 by 2, v raised to 1 by 2, w raised to 1 by 2 plus u raised to 1 by 2, v raised to minus 1 by 2 into w raised to 1 by 2 du dv dw, provided u plus v plus w is equal to 1. Clear? Now by Dirichlet's theorem we can use. By Dirichlet's theorem, so gamma of 3 by 2, gamma of 1 by 2, gamma of 3 by 2. Four a raised to 7 into pi upon 8.35 into 35. So you will get 4 to the 8. So there are 8 octants. So you will get for the 8 octants, 8 get cancel out. So 4 raised to 7 by 35. 4a raised to 7 into pi by 35 for the 8 octant. This is for the 1 octant and there are 8 octants. So 8 into this integral. So you will get 8 cancel out. So 4a raised to 7 pi upon 35. Okay. Now let's see. Find the volume. You will get find the volume. Now see. Find the volume bounded by the to the common right circular cylinder. X square plus y square is equal to a square and x square plus z square is equal to a square. So right circular cylinder. We will draw the right circular cylinder here. So for this right circular cylinder. Hmm? Square plus z square is equal to a square. Right? So now we can see this is the common part. Now the volume enclosed by the cylinder, we get y is varying from where y is equal to plus or minus root of a square minus x square and z is equal to plus or minus root of a square minus x square. Right? So on the xy plane, z is 0. Z is equal to 0. Now x square is equal to a square, which implies x is equal to plus or minus a. So where a is varying from? So volume V is equal to integral x is varying from minus a to a, y is varying from minus of root of a square minus x square to root of a square minus x square, and integral z is varying from minus root of a square minus root of a square minus x square plus root of a square minus x square. So here dx dy dz dy dx. First integrate with respect to z. So which is equal to 2 times integral from 0 to a dx into 2 times, because minus infinity to infinity. So 2 times integral from 0 to root of a square minus x square dy into 2 times integral from 0 to root of a square minus x square dz. So you get 2 into 2 into 2. So that is 8. 8 into integral 0 to a dx, 0 to root of a square minus x square dy into now z. Or integration of z dz. Root of a square minus x square. Right? So which is equal to 8 into integral 0 to a dx So volume is V is equal to 16 A cube by 3. I hope you are getting it clearly. The first important thing is that here how to write the integral limits. So see here y is varying from where to where. So y square is equal to a square minus x square. So y is varying from 0 to root of. Take the square root on both sides. So we'll get root of 0 to under root of a square minus x square. Find the volume of the tetrahedron bounded by the coordinate planes and the plane x plus y plus z is equal to 1. Now since the volume is triple integral dx dy dz. So volume is bounded by the coordinates plane x is equal to 0, y is equal to 0, z is equal to 0 and x plus y plus z is equal to 1. So since the limits are so tetrahedron x to y. So we converted into xy plane first. Draw the strip parallel to y-axis. So you will get here the same plane z is equal to 0. The same plane is look like this, right? So z0, so x plus y is equal to 1, right? So z is varying from 0 to x plus y is equal to 1. Plus y is equal to 1. This is the plane, right? Now write the integral limits. So volume V. So for z is equal to 0, so z is equal to 1 minus x minus y. For y is equal to 0, 2y is equal to 1 minus x. So x is varying from 0 to 1, right? X is varying from 0 to 1. So I is equal to integral 0 to 1 dx. Integral y is equal to 0 to 1 minus x dy. Integral z is equal to 0 to 1 minus x minus y dz. So which is equal to integral x is equal to 0 to 1. So integral of this keeping x constant into y minus y square by 2 from 0 to 1 minus x dx. So integral from 0 to 1, just put the integral limit. So 1 minus x bracket square minus 1 minus x bracket square by 2 dx. So here integral 0 to 1. Now 2x minus. So you will get 1 by 2 into 1 minus x bracket square dx. So 1 by 2 into integral of this is 1 minus x bracket cube by minus 3. From 0 to 1. Put x is equal to 1, this will become 0. X is equal to 0, so minus of minus 1 by 3. So again answer 1 by 6. So the volume is 1 by 6. Okay. I hope you are getting it clearly how to find out the volume of a tetrahedron bounded by this. Okay. We will get the clear-cut idea how we use the triple integration to find out the volume. Okay. To find out the volume, here we used the triple integration. Okay, there are many examples we can find out the volume, so that we will see in the next lecture. Thank you so much. If you are like my videos, please do like, share. If you are liking my videos, please do like, share and subscribe. And don't forget to use my promo code DSP. And don't forget hit the bell icon for the further notification. Okay? And join our Telegram group for the latest updates on your upcoming videos.